homework? Do you have any questions on the homework?
Yes.
Yes? You're also supposed to turn in that quiz, that group quiz, so please bring that up here. And if you weren't here last time, you can come get your exam. It's yours. I'm just right over here. So the questions on the homework.
Yes.
Okay, what would you like me to look at?
Number 3.
Was that 2x minus y equals 5, that one?
Nope.
Oh, I'm looking at the, sorry, I'm not looking at the homework.
In my packet,
X over 2.
x over 2 and then x plus y over 3 equals 4. And
Whoa,
they were telling me in the lab
that's a typo. Yes, that is a typo.
1 over 2.
Yeah.
Are you sure?
And number 3. See if it's the same for
Yes.
all of ours. It says x over 2x plus y over 3 equals 4, and then 3x over 4 plus 5y equals 33. That's what it says. Do you have the same thing? Okay, yeah, this is definitely a typo. So this should probably be a 1. So shall we work it out? Yes? All right, so this is a system of equations. And we have 2 methods, right? So which method? I told you should try both, right? So let's try the first method. See if you can remember the steps. First thing you'll do is solve one of the equations for any of the variables you want. So these all have fractions. They're all pretty ugly. So any requests?
Get rid of the fractions.
Pardon?
Get rid of the fractions.
You could get rid of the fractions to start, right? But at the end, you're going to wind up with fractions again if you do that. Because you'll have to divide through, oh, well, yeah, you'll have to divide through, multiply by 3. You'll still have fractions, right? I mean, you can't totally,
I mean, you do, but you don't get the fractions for the answer.
well, for the answer, maybe not, yeah. Let me do it this way. I'm going to take the first equation, I'm going to solve it for y. Is that fair? Okay, so I'm going to take this first equation, 1/2 x plus y over 3 equals 4, and solve for y. So first thing I'll do is just move the 1/2 x to the other side. And when I do that, it becomes negative 1/2 x and then plus 4. So I still have the 4 here. This came over. That's good. And I almost have y by itself, except I need to get rid of a 3 that's being divided. So how can I do that? Multiply both sides by 3. So I'm going to multiply this side, left side by 3. And I have to multiply the entire right side by 3. And that will get rid of the 3 on the bottom over there. And so what am I left with on the left side there? Left side. Just y. And then when you distribute this 3 through, what would we get? Come on, we got one more day. We can do it. Huh? Negative 3 over 2x. So you're multiplying negative 1/2 times 3 over 1 straight across. And then you still have the x there. And then what? Plus 12. There we go. So we have picked an equation. We solve for the y variable. Once we do that, we substitute this into the other equation for this y. So I'm going to replace in the second equation 3x over 4 plus 5. Now in parentheses, this thing right here. Negative 3 halves x plus 12. And then what? Equals 33. So that's rewriting the other equation, replacing the y. Now this equation just has x in it, so we'll try and solve for x. But to do that, we first have to free it from the parentheses here, so we'll have to distribute a 5 through. So when I distribute 5 through, I will get 3x over 4. Then what? Come on. What is it? Negative 15 over 2, x, and then 5 times 12 plus 60 equals 33. I can put these two together if I can get a common denominator, right? So I need a common denominator of 4, so I have to multiply the bottom and the top by 2. So I'm going to have 3x over 4 minus, 30 over 4x. And then how about over here, how about I subtract 60 on both sides? And when I do that, I should get negative 27. Now, this is kind of weird the way it's written. They have 3x over 4, and here we have 30 over 4x. So please keep in mind that this is the same as 3/4 x minus 30 over 4x. These are the same expressions. So what do I get when I put those together? 3 take away 30, so negative 27 over 4x. And on the right side, negative 27. We're almost there. Multiply both sides by the reciprocal. So I'll multiply the left side by positive or negative? Negative, because I want it to multiply to be a positive. So negative 4 over 27. And just remember that negative 27 is over 1. And the left side should just turn out to be a positive 1 sitting in front of x. Right? Like that. And then over here, the 27s cancel, right? And you have a negative times a negative, which means you'll have a positive 4. So x is 4. So that's a nice answer, considering we had a lot of fractions in here. And then once you have that answer, you take that and substitute it back into the equation that you had solved for y, which I erased. But it was this. It was y equals negative 3 halves x plus 12. Right? That's what it was. And I just replaced this x with 4. So y is equal to negative 3 halves times 4 plus 12. And when I multiply these two together, this is like a 4 over 1. So you go straight across. You should get like negative 12 over 2, which is the same as negative 6. So I'm almost there. So y is 6. So my final answer is written as an ordered pair. It's the point 46. So these two lines intersect at that point. We good? Y'all are killing me here. All right. Should I do it with method 2, or should I leave it as is? What do you want? No?
Just I did it differently.
Mm-hmm.
And I still got the right answer.
That's okay. That's okay. We're all going to have some variation in the way we do this. You know, it's going to depend on which equation you pick, what variable you solve for. If you cleared the fractions first, your work's going to look a little different, but we should all end with the same thing. Okay, what else can I look at here? Y'all are ready to be tested over this tomorrow? That's what's about to happen, right? So now's the time to ask questions.
Can you do number 1 on 107?
Okay, so that's 2x plus 3y, that one? Okay, so 2x plus 3y equals 24, and 7x plus 8y equals 64. Now let me just ask you, if you were doing this on the test, what method would you pick and why would you pick it? Anyone? Method 2, why? Because what? Everything's already moved over to all one side. So yeah, that's one thing we could look for, is if everything's already x's, y's, and numbers, then method 2 is kind of ready to go. But there's something even, I guess, more than that you should be thinking method 2.
I think method 1 is easier because you're going to have to cancel that. So I feel like the multiplication would be more complicated.
Okay. So like you think solving for y on this would be easier than trying to get one of these to cancel?
Yes.
Okay. Well, I agree, but I only agree because I didn't really show you how you can attack something like this last class, which is what I was hoping you'd run into in the homework. Like how would I do method 2 on this one, right? Because it's not an obvious way to get these to cancel. Y'all understand? Like if this was a 4, then you'd be in business, right? Because you could just multiply the top one by -2, and they would cancel right away. But because it's a 7, that's not so obvious. Like, what do you multiply 2 by to make it kill off a 7, right? So instead, what we do is we think of a common multiple of both of those numbers, 2 and 7. So what's a multiple of 2 and 7? 14. So can you turn this one up here into a 14? Sure, multiply the top equation by 7. Now we need to make this one not a 14, but a -14, so we multiply by -2 on the bottom equation. So you're going to do them both at the same time, and you're going to, that's right, you didn't know that, and that's why I wanted you to do the homework and see how you're going to handle that with method 2. So let me just rewrite this system of equations real quick. And wouldn't you get 14x plus what, 21y equals 168. And then when you multiply the bottom equation by -2, you get your -14x minus 16y equals -128. Agreed? And so we've used this balancing of equations that you can multiply both sides of the equation by the same number and it's still the same equation to kind of massage it into something that we like, right? This is something that's going to work for us. Now we just add straight down and we get what? These go away, right? This is 5y and this right here is 40. And we're there, right? Y is what? Y is 8.
Is there a time when you can't find 2 multiples?
The previous problem that we did, where we had all those fractions, would be a little harder to do this method on, right? Because you had fractions. But I can show you how you could have done it on the last problem. So your answer is no. I mean, you can always do this. You just have to be able to come up with the right numbers here. All right, once I have that y is 8, I can take that and I can plug that into any equation I have, right? So I'll just plug it into the first one. 2x plus 3y equals 24. I replace y with 8. And 2x plus 24 equals 24. And you might have had a little bit of a problem with this, okay? Which is, I've seen, you know, it's kind of normal for people to struggle with this a little bit. Subtract 24 on both sides and you get 0, don't you? So you get 2x equals 0. And people are like, what? What do I do with that? Well, just divide both sides by 2 now. So if I divide by 2, I get x equals, well, 0 divided by 2 is 0 still. So x is 0. So your answer is the ordered pair 0, 8. Remember, you can't have division by 0, but you can't have a 0 down here, but you can have a 0 up here. All right. How are we doing? Is that okay? So do you want to see method 1 with this one, or do you want me to go back to the previous problem and do method 2 with the previous problem? Or do you just want me to move on to something else? Yes? Method 1 for this one? Okay, so method 1 for this one, we should still get the same answers, right? 0 and 8. What I would do for method 1 is I would just pick one of these and solve for x or y. And what? You want to go y on the first one? Did you try this one yet? Did you go y on the first one? Yes? Okay, that's what I'll do. So I'm going to take the first equation and I'll solve for y. So I'm going to move this to the other side, which makes it negative 2x. And then divide everything by 3. And I'm going to get fractions. At least I'm going to have a fraction on the x. This divided by 3 is 8, right? 24 divided by 3. So that's not so bad. And then I take this and I replace it into the other equation for y. Y'all look so tired. Y'all are making me really sleepy up here right now. All right, so there's the second equation, replacing the y, right, with what we just got. And now distribute the 8 through. So here and here. 7x, let's see, what is that going to be? Negative 16 over 3x, and then 8 times 8, 64 equals 64. And you can see right here that those are going to go away, right? You're going to subtract and you're going to get 0. So you get 7x minus 16 over 3x equals 0. And you'll have to put those two together. So what's that going to be? 21x, or 21 over 3x minus 16 over 3x equals 0. And when you subtract those, you get 5 over 3x, 5/3 x, equals 0. And then the same exact thing that we just had. 2x was equal to 0. We divided by 2. Didn't matter. 5/3 x equals 0. Doesn't matter. This just gives you x is 0. Once you have x is 0, you go back, you plug into the other one, you should get 8. Clear? Good. Yes?
I have a question on number 2.
Okay, on number 2?
Yeah, so if you do the method 2, and you times the first one by 3,
Mm-hmm.
they both cancel out like the x and the y.
Yes.
How do you know which one is which?
Yeah. Okay. All right, so you did method 2 on this, and you multiplied the first equation by 3? Okay. So when we do that, we get a new system, 6x minus 3y equals 15, and negative 6x plus 3y equals 7. And then when you add the 2 straight down, the x's go away, but so do the y's, right? And you get, what, on the left side, that's 0, right? You get 0 equals 22, and that's not true, so no solution. These are parallel lines. That's what this means. Remember, there was 3 possibilities, right? You could have an answer like we had over here, 0, 8. You could get something absurd like this, which would mean the lines are parallel. Or the third option was that you could get something right here that actually makes perfect sense. Like you do this and, well, maybe you get this. The left side, everything cancels out. You get 0, but on the right side you get 0 also. And then what would that mean? It's the same line. And so you could just write that same line, infinite solutions, whatever. So no questions on the word problems? The third word problem? Is this a farm and pigs and chickens? All right. On a farm there are pigs and chickens. Total of 17 animals. There are a total of, whoa. What?
Yeah.
Oh my goodness. I just want to say I had nothing to do with this packet, okay? Nothing to do with it. I would never, ever have put something like that out. Well, it's obvious if you have pigs and chickens, then, 58 feet, right? It all makes sense. What? What? Wow.
Doesn't even make sense.
Wow. I've stopped making notes on the errors in this thing because, sometimes you just have to blow it completely up and start over, right? This is one of those things that I think needs to be blown up and started over. So I guess we're not doing that, number 3. And what would we do with it? I mean, what is there to do? Is it feet like feet? Oh, feet. They're talking about feet. Like appendage feet. Well, I suppose we could do that. I still think it's not well written. Right? I guess I'm so ready for a mistake here that I'm not reading it the way it needs to be read. I'm like, okay, they just like copied and pasted from another problem. They're talking about measurement feet. All right, let's look at his feet. Let me draw some pictures. Okay, so here's a chicken. And we're going to say that the chicken that's a good chicken. That's a real good chicken. Thank you. A chicken has 2 feet, right? And a pig, fortunately for us, our pig, sorry, I didn't grow up on a farm or anything, so I'm going to do my best here. Okay, so there's, hey. Okay, I'll get the tail right at least. Wow, that is a cow. All right. So there's a 4-footed pig, right? And a 2-footed chicken, pigeon, whatever. And we have a total of how many of these animals?
We don't know.
We have 17 of them. And we have 58 feet total. So how many of each animal are there? So how many of each animal, right? The first thing I said is assign your variables. X, let's just call that the number of chicken. And let's call Y the number of pigs. So when you take the number of chickens and the number of pigs together, how many should you have? 17. So we know that X plus Y is 17. Right? The total number of feet is 58. For every chicken, we have how many feet? 2. For every pig, we have 4. So I know that I can say what? You tell me. What can I say? 2x plus 4y should equal 58. Those are the 2 equations. I feel bad now. I guess we could have done this problem, but just, like I said, I'm just so prepared for there to be mistakes in here that when I read something like that, I don't interpret it the way it's supposed to be. All right, there's our system. Method 1 or 2? I like method 2 here. I can kill off those x's pretty straight away, right? -2 up top. Go through, add down, should work. Let's see. Sorry, guys. All right, so I have -2x minus 2y equals -34, and then 2x plus 4y equals 58. And when we add down, we get what? 2y equals 24, which means y is 12. We have 12 pigs. To get x, you go back and replace any equation, right? With replace y with 12 in any of the equations. So that first equation we had, the easiest one, this one right here, I just replace that with 12 and I'm done. You could probably just think about it too, right? Obviously, if you have 12 pigs, you've got to have 5 chickens to get 17 animals. So 5, 12. Now that's not a point, right? We're not really looking at these as lines anymore, right? Because it's got a word problem attached to it. But we turn the word problem into the math and then take the math and kick back an answer that makes sense in the word problem. All right. Any others? Medical problem, boxes of fruit, anything like that?
Number 6.
Test, let me read this carefully. Is this a test has 20 questions?
Number 5.
Oh, I'll still read it carefully. A landscaper is designing a park. Is this the one you have?
Yes.
And placed 2 orders with the nursery. Nursery, I guess, sells plants and stuff, right? The first order was for 13 trees and 4 bushes and totaled $1,075. The second order was for 6 trees and 2 bushes, totaled $500. What is the cost of 1 tree and 1 bush? So we're assuming the cost didn't change, right? It was the same each time he ordered. So X is going to be equal to the cost of 1 tree. Y will be equal to the cost of 1 bush. And tell me about his first purchase. 13 trees and 4 bushes. So he paid 13 times however much a tree cost, and he paid 4 times however much a bush cost. So it should look something like this. 13x plus 4y, and that cost him in that first purchase $1,075. In the second purchase, 6 trees and 2 bushes totaled $500. Make sense? Ooh, I like this one. Method 1 or 2 here? You want 1?
We have to use it for both, right?
You would have to kill off the x's and do both, or Mom?
Can you kill off the y?
Yeah, why don't we kill off the y's instead of the x's? We haven't done that, but I told you get to pick. Wouldn't it be easy to kill off the y's? Just turn this into what? -4y. So I just multiply by -2 here. If I do that on the second equation, I should be in business. So if you like method 1, go for it. I'm going to stick with method 2 on this one. 13x plus 4y equals 1075. That one's not going to change. This one I have to hit everything with negative 2. So negative 12x, negative 4y equals negative 1,000. Ooh, that's going to be real nice. Because when I add down, look at the x's. 13x take away 12x's. It's 1x. The y's are gone. And you get what there? 75? And x was the cost of a tree, wasn't it? So I already know what x is. I'm done. I know a tree costs 75 bucks. Now to get the bush cost, I can go to any equation I want. So I'll go with the first one. 13x plus 4y, sorry, plus 4y equals 1075. And just be careful here because we're replacing the x with 75, not the y, right? We solve for x. So 13 times 75 plus 4y equals 1075. What is 13 times 75? 975 plus 4y equals 1075. Subtract 975 from both sides. And you get 100. Wait, is that right? No. What is it? It is 100. So 4y equals 100. So y is 25. Tree costs $75, the bush costs 25. All right. I think that's good. You good? All right. We are going to talk about one more thing. And I told you, I think it's really just going to be a glossing over of this topic. It's very brief. We're not going to get into the detail of it because all I want to be able to do is use this to go back to a problem that we did before that involved interest in bank and putting money in your bank and things like that. So, let me title this section first. Logarithms. If I asked you to do this, I'm going to say recall. If I asked you to solve this equation right here, you could do that, right? Everyone's comfortable with this? Move the 5 over, subtract 5 on both sides, divide by 2, you're done. We know how to handle that. I'm going to put a check there. If I asked you to solve this, that's a quadratic equation, and you could solve that, right? Everyone would be comfortable with that? You could factor it, perhaps, if not the quadratic formula. If I asked you to do something like this, you could try to do that. You could do like a GCF first, right? GCF here would be x, and then you could work on what's there. And we would possibly, I'm going to put kind of a cautious check here, that we might be able to do that. Might, right? This would be like when you were graphing those polynomial functions, you had to find the x-intercepts. This would be something like that. We can handle solving those types of equations. How about solving something like this, though? What's different? X is up here in the exponent, right? When you look back at all these problems, this x lived on the ground, right? On the base. It was in the base. The exponent was never x, right? The exponents were just numbers up here. That's even a 1 up there. So we never had the exponent be up there. And so the question becomes, can you solve this for x? Well, your first natural move might be to do what? What looks the most natural to you to solve that? Subtract 3 on both sides, right? So you get 2 raised to the x equals, what's that, 8? Agreed? And can you solve that just mentally? Can you think of something that would work? What? 2 to what power is 8? Third power, right? 2 times 2 times 2 would be 8. So you could get an answer here of 3, and that would work, right? But what that required was that you could look at this and know the answer, right? There was no like algebraic move that I used to somehow like get that x out of the exponent. And that's what I want to do to end out this class, is teach you how to remove x's from exponents. So what I'll do is I'll just tweak the problem just a little bit. I just want to just change one little thing here. Let's change that to a 10 instead. Now things get a lot more complicated, because if I subtract 3 on both sides, this is now a 7. So can you tell me what power I raised 2 to in order to get 7? You're not going to be able to come up with the answer, are you? Like, it's not in your head. Like, obviously 2 times 2 times 2, that's 8, but this is 7. So do y'all see that this is not going to work this way? All right, so this becomes the question. How do we do this? All right? So we are going to use what's called logarithms to do this. And trust me when I tell you, I'm giving you a very, 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 very watered down version of logarithms. In fact, I'm almost treating a logarithm with disrespect here, all right? But it's just a tool we're going to use, all right? That's all it is. So here's the symbol for what we call the natural log. The natural logarithm. It's on your calculator. It's an L followed by an N. It is not an I followed by an N. And I believe it's written that way because originally it was French, and you know how the French, they wouldn't say natural log, they would say logarithm, natural, or something like that. They do it backwards. Same sort of thing. So log, natural. Got it? Everyone see it on their calculator? All right, now this key is very important, and it's connected to the E key. In fact, it might be above your E key. Remember the E that we used already? That was that natural base. You might have to hit Shift in order to get to this natural log, or it might be a separate key. How many of you have separate key? Separate key. I have separate key here, so you should probably, oh, the E is the shift on this one. Okay, so see, they're connected to each other. And the reason they are is because they're what we call inverse functions. But again, this is the super watered down, nobody's getting drunk on logarithms today, all right? It's going to be very, very basic, all right? So how are we going to use this key, all right? What is it going to mean to us? Here's what it's going to do, all right? I'm just going to show you this one property, and from there, believe it or not, we'll be able to solve that problem, all right? Here we go. So the property we're going to use goes like this. If you take the natural log of something, I'm going to call it x, it doesn't matter what it is, and that x is raised to a power n, that this is equal to n times the natural log of x. So essentially this property tells you that if you place a natural log in front of an expression that's being raised to a power, you are allowed to take that power and drop it down. Okay, you see how the power just drops down? That's what happened here. Understand? We're not going to discuss why it works or anything like that. You're going to take that on faith, all right? Got it? Now, let's get back to this problem right here. I'm trying to figure out what x is, right? But x lives upstairs. I need to get it out of there so that I can get an answer. X equals something, right? The only way you can drop something out, a power, drop it out like that, is if you had a natural log sitting in front of it, because then you can drop it out. So what I need to do is come in here and introduce the natural log into the equation. And it's kind of like when you do like multiplying both sides of an equation by something, or adding. We're going to do natural log on both sides. So watch my next line. It's going to be natural log, and I'm going to put this in parentheses, 2 raised to the x equals natural log, and I'm going to put this in parentheses also. Please understand that the natural log is not a number. We're not multiplying both sides by natural log. We are taking natural log on both sides of the equation. We are using a function, not a number, on both sides of an equation. Again, watered down, asterisks, math gods, please don't be upset with me. I'm just trying to get through this, all right? All right, so now, looking at this, can I remove that x? Can I drop it out front? Yes, because of the property I told you to believe. So if I do that, the next line will look like this. X times natural log of 2 equals natural log of 7. And by freeing the x up and taking it out of the exponent, now you treat it more like a linear equation and you just solve for x. So if I want to solve for x here, I need to divide both sides by what? I need to get this out of here. So your next step is to do x equals natural log of 7 over natural log of 2. Understand? Now, on your calculator, I'd like for you to do this. You will have you get your natural log key, you type in natural log 7, close the parentheses, divide natural log 2, close parentheses, enter, and you get what? Yep, approximately 2.807. So I know people are using different calculators here, so you want to make sure that you can get to this answer. And that's it. That's the answer. So if you go back and look at what we were asking, we're saying 2 raised to what power is 7? Well, that's the power. And if you don't believe it, use your calculator and type this in. 2, use that little caret key, 2 raised to the 2.807. We rounded, so try that on your calculator, and I bet you it's going to be really close to 7. 6.99 something. So the more decimals you use here, the closer you get. Yes?
Log is like invert LP.
Yes, uh-huh.
Would you just plug in, how would you just plug that in?
Plug what in?
Or not plug it, but would you just put like E7 or something? Or how would you do that like that?
How would you do that one backwards?
Yeah, with the
Are you trying to solve this same problem using the E key? I'm not quite sure.
I don't know how to ask that question.
Okay, if you can reframe it in your mind and have a better way of getting it to me, then let me know. All right, let's do another one. All right, I would like for you to try this one. 5 to the x minus 3 equals 21. So is this obvious to you that this is a exponential equation, that your exponent is where the variable is? Try it yourself first. Show me your hand if you've got it. Okay. I rounded 3 decimal places. 1.975? Is that what you got? Approximately? 1.7? No. Did you do? You know what you did wrong though? Okay. Now you have to be careful, okay? On the final, I'm going to put a couple of these on it. I mean, you got to be on. I mean, you got to get these right. I mean, because there's not a whole lot to do here. You just have to move things around, use your calculator. So, you know, wrong is wrong. So you be careful when you're computing these.
And you want us to round?
3 decimal places is good. Yep. If you put 1.974, I wouldn't take off. All right, let me try and make this a little harder. I'm going to give you a small little hint here. When you're using that property, remember pulling the thing out front? The whole thing gets pulled out front. So if you bring in natural log on both sides, that whole thing drops out front. Not just the x, not just the 2x, the whole 2x plus 1 drops. I'll let you work it on your own. I'll work it on the board. See if you follow this. Add the 5 to both sides. Take natural log both sides of the equation. Pull the entire power out front. Put it in parentheses because it's got 2 terms in it. It's got to be in parentheses. The whole power came out front. And now what? Divide by the natural log of 3, right? Okay, so if you divide the left side by natural log 3, you do the same thing to the right. You're left with the 2x plus 1 still over here. The right side you're going to need your calculator for, and go ahead and do that on your calculator and see what you get. What is it? 0.288. Uh-oh, 3 point something, uh-oh. 3 point, double check that. This one right here. Natural log 45 divided by natural log. You did what? Okay, but you typed it in as 2, you should hit the natural log key twice. Did you do that?
Yes.
Okay. Here's a mistake I see people make. They'll do this on their calculator. You can't do that. It's got to be natural log 45 divided by natural log 3. 2 separate natural log terms. So natural log 45 divided by natural log 3. 3.465. So this is approximately 3.465 2.465. And over here, 2x plus 1. And you're not done. You have to solve for x. So now it's just a linear equation. Subtract 1 from both sides, divide by 2, you're done. So I'll finish it up. Subtract 1, you get 2.465. Divide by 2, you get approximately 1.232. Anybody else agree with that? Yes? Okay, that's it. Make sense? Right.
What is it the equal sign or is it the approximate?
Well, when I said approximate here, that pretty much meant from there on everything was approximated. You could continue to do this if you want to. As soon as you say it once, though, everything after that is understood to be approximated.
As long as you say it
Yeah.
once, it matters
Yeah.
every time.
Even if you forgot to put it, I wouldn't take off. You know. All right. You plan to invest let's make it $12,000 into a simple interest account. Which is compounded continuously at a rate of 2.75%. So you got a good rate here. This sound familiar? We've done problems like this. What I would normally ask you at this point is how much would be there after 2 years, or how much would be there after a year, or how much would be there after 10 years, right? That's what I would normally ask you. Now I'm going to ask you something different. How long will it take to double your money? How long is it going to take for you to double your money? So what I'm going to start with is asking you, which formula do we use for this situation? The PERT. You know, I saw a PERT shampoo commercial the other day. I haven't seen one in a long time, and I happened to see one like the day after we talked about it. PERT. Right? That was it right there? All right. Do we know any parts of this formula? We know what P is, right? P is the amount that we put in, right, to start. What else do we know? The rate. We know that is 0.0275, right? Time is what we actually want to know, isn't it? How long? Right? How long does it take to do what? Double our money, which means at the end of that time, we want this to be what? 24,000. Understand? Continuously means we use the PERT formula. That's what, if that's a compounded monthly, we would go use the other formula. So this is, I'm going to just transform this now. This becomes, the left side is 24,000 because we're looking to double our money, right? Equals 12,000 e to the 0.0275 t, right? That's the problem right there. Understand it? T lives up in an exponent, and we need to get it down. But we can't get it down yet. We have to take care of this 12,000 that's sitting in front of it. So how can we eliminate the 12,000 sitting in front of it? What's that? Divide it on both sides. Pardon? That's what you meant? Yes.
Where did you get the 24,000?
Oh, okay. Where did it come from? We're looking to double our money. Okay, so if it said triple your money, 36,000, right? Or if it just said, how long will it take to have 18,000 in there, then you would just put 18,000. Understand? All right, so let's divide both sides by 12,000. I'm dividing because that's multiplication. So I'm undoing it, I divide. So the left side becomes what? 2. Just 2, right? Okay, and then the right side is e to the 0.0275t. Now, remember, e is just a number, right? E is just a number. I'm ready to come in with that natural log on both sides of the equation. So I'm going to do that right here. I do natural log of 2 on the left side. I do natural log of e to the 0.0275. Yeah, t, like that, right? So I've done natural log on both sides. That, in effect, allows me to take this right here and drop it out in front, right? That's what I'm going to do on the next line. So my next line will look like this. Natural log 2 equals 0.0275t times natural log of e. I know that natural log e looks weird, but in the previous problems we had like natural log 5, natural log 2. It was natural log of a number. We still have the same thing happening here. Now, I wonder if you're going to be able to figure out what natural log of e is on your calculator. It's one, are you getting 1 on your calculator? I want everybody to try it, and I want everyone to get 1. Yes? If you're not getting 1, let me know. Got it? You got error. Okay, let me take a look. Oops, sorry. Is that a blanket? Oh, a little sweater. Thought you brought a blanket to class.
Do I need to put a 1 in that at?
Yes, in that little space right there, put e to the 1 power.
Okay.
You got it? Now, because this is the watered down version of natural logs, I'm not getting heavy into this. But the reason why this is always going to turn into 1. The natural log of e is 1. Always. And it's because they're inverse functions and they undo each other, and basically it turns into 1. All right? So water it down. That's it. So anytime you're doing a problem with this continuously compounded interest and you're trying to figure out how long it takes, you're always going to get this natural log of e. And it's always going to turn to 1. So really at the next line, it's not there. Right? I mean, that's it. We're just to this now. And to get t, I will divide both sides by 0.0275. This equals t. And so do that on your calculator. And let's see how long you're going to wait to double your money. 25.2 years. By the time you double your money, because of inflation, it's going to be worth less than